Hi all. Now we have just 2 weeks in front of us before the board exam. You might have already studied really well, and now it's time to apply what we have studied. You already know that the pattern of the question paper has changed. Earlier, all the questions of physics, chemistry, and biology were mixed together, whereas now onwards we should write it separately. And CBSE has told that if you write the answers in between the other subjects, like if physics answers are written along with biology or chemistry, you won't be awarded any marks. So please take care of that one. And one more thing is, now the paper is separated. So first you will be writing biology, then chemistry, and third part is physics. For us, question number 30 to 39 are physics questions. One disadvantage that we speak about CBSE is we won't be able to predict 90 to 95% of the questions. We can't predict any exact questions because it will keep on changing. But another advantage is we will be able to predict exactly from where the question will be asked. The way in which the question will be asked will be different, but from where the question will be asked will be same. And the pattern of the question paper won't change. Almost 90-97% of the questions of the pattern will not change at all. So this time, let's have that strategy in our mind. We'll take few question papers, then we'll discuss the questions in the order. We'll start with question number 30, then 31, 32 of 4-5 question papers. So that we'll get an idea of what type of question will come and from where it will be asked. Okay, come, let's start. As per the model question paper released by CBSE, for physics, we have 3 MCQ questions. And in that question paper, all the 3 questions are coming from light chapter. Even the third one is assertion reason question. That is also coming from light chapter. There can be minute changes, but still the possibilities are to maintain this one. So the first question is coming from the first chapter of light. And second question comes from the second chapter of light. And again, assertion reason is coming from the light chapter. So let's go to the first question, that is question number 30. In this first question, if a lens can converge the sun rays at a point 20 centimeter away from its optical center, the power of this lens is. This is the question. So a lens can converge. The word converge is important for us. Then at a point 20 centimeter from its optical center. These 2 points are important. We already know we have 2 types of lenses, that is converging lens and diverging lens. So a convex lens is usually a converging lens which converges the light rays, and concave lens is usually a diverging lens. It will diverge the light rays. So here indirectly they are telling us it's a converging lens, that is convex lens. Okay. So one more point is the sun's rays. We know that usually the ray that is coming from the sun will be parallel. So they are telling us through a convex lens, parallel rays of light is coming and it's falling and it's getting converged there to a point 20 centimeter away from its optical center, which means here 20 centimeter from optical center. We know that whenever parallel rays of light comes and hits a convex lens, it will converge at a point. That point is called the focus, the principal focus. So here indirectly they have given us the principal focus as well. So when they say lens can converge, they mean it is convex lens. When they say sun's rays, they mean parallel rays of light is coming from infinity. Then 20 centimeter from its optical center. We already know that parallel rays of light will converge at a point, that is principal focus. So indirectly principal focus is given, that is 20 centimeter. Now the question is the power of this lens. For convex, usually for convex, doesn't matter whether it is lens or mirror, for convex the focal length is always positive. Since focal length is positive, power is also positive. This is a common rule. Then for concave, it is the opposite. For concave, the focal length is negative and the power is also negative. Keep this in your mind. Now come to the point. Here we have to find out the power. We know the equation for power. Power is equal to 1 by focal length. And the focal length should be in meters. Here the focal length is given in centimeter. That is 20 centimeter. When we convert that to meter, it is 0.2. So it is 1 by 0.2. So now if you multiply with 10, numerator and denominator, then we'll get 10 divided by 2. That is 5. We know the SI unit of power is diopter. So it is plus 5 diopter. And the answer is option C. Option C is the correct answer. Going to the next question, that is question number 30 in another question paper. Which of the following statements is or are true? We should find out which is true. First statement is a convex lens. A convex lens has 4 diopter power having focal length 0.5 meter. Let's make use of the point that we have told just now, that is convex. If it is convex, irrespective of lens or mirror, it will have a positive focal length. Then if it is concave, then the focal length will be negative. Here let's see, a convex lens has 4 diopter power having a focal length of 0.25 meter. So here the convex lens power is given as positive, which is possible. So let's see whether this value is correct or not, 0.25 meter and 4 diopter. So if focal length is 0.25 meter, then the power is the reciprocal of it, 1 by f, that is 1 divided by 0.25. 0.25 goes 4 times in 1, so it is plus 4 diopter. Answer is plus 4 diopter. So the first statement is correct. We have got the answer, but still we'll go to the next one and see. A convex lens has minus 4 diopter. Minus 4 is not possible because it's convex. So second statement is wrong. Go to the third one. A concave lens has 4 diopter. We already told that for concave, focal length is negative. But here it is positive, which is not possible. So that's a wrong statement. Now, a concave lens has minus 4 diopter having a focal length of 0.25 meter. It's concave lens, its power can be negative, that is correct. But focal length is given as 0.25 meter. Here focal length should be a negative value. But here it is positive. Again this statement is wrong. So only correct answer is option A. Now you might have got an idea about how question number 30 from the light chapter will come. Now going to question number 31. Here a prism ABC with base BC. So BC is the base of the prism. Is placed in different orientations as you can see in the image. A narrow beam of white light is incident on the prism as shown in the figure. In which of the following cases, after dispersion, the third color from the top corresponds to the color of the sky. We know the color of the sky is blue. So they are asking when will be the third color from the top be blue, in which orientation. Okay, before going to that, let's see what happens in prism. So when we have a prism, if this is the base of the prism, then if light ray, white light is coming from here, it will get dispersed like this. So on top you will have red, at the bottom you will have violet. Order will be violet, indigo, blue, green, yellow, orange and red. Okay. So as per the question, the third color should be the color of the sky, which means blue. Third color should be blue, which means this should be the order. If you keep the prism like this, it's not possible. So they are asking us the question where the prism is inverted. So if you keep the prism in an inverted way like this, then we'll get blue on top. So instead of R, O, Y, G, we will have V, I, B, G, Y, O, R, where the base will be on top. So in the option, look for a prism where the base is on top. So here they already told us that the base is BC. Here the base BC is at the bottom, which is not possible. Here base BC is here towards the right side, not possible. Here base BC, here it is on top, so this is possible. Anyway, let's see the last option also. Here base BC is towards left side, not possible. So our correct option is option B. This is the reason. So questions related to this color used to come always for the exam. So please do study this order. So the bottom one, the light which bends maximum will be violet. The light that bends minimum will be red. Please study this order. Let's see one more question. In this question they are saying that the path of a ray of light coming from air passing through a rectangular glass slab traced by 4 students are shown in the figure A, B, C and D. Which one of the following is correct? We know that if we have a glass slab and if the ray of light is coming and striking here, instead of going in a straight path, it will bend towards the normal. In the class we have already discussed that. Those who haven't seen that, please go back and see the classes. Again, after coming out, it's coming from denser to rarer medium. It will go back away from the normal. So here it's coming from rarer medium to denser medium. It will come towards the normal. Here it's going away from the normal because it's coming from denser medium to rarer medium. So it will go away from the normal. The thing is, this ray, the incident ray and the emergent ray, both at last when we look will be parallel to each other. That's the case. So in the first case, this is not possible because here it's not bending at all. It's just moving as it is. So this figure is wrong. In the second figure, it's coming, bending towards the normal. It's moving away from the normal. And these two lines, this line and this line, both are parallel. So this can be correct. Anyway, let's see the other options as well. Here it's coming from the air to the glass, but here it's not bending, which means it's wrong. Again, here it is bending, but while coming out, it's not bending at all. So this is also wrong. So our correct statement is, the correct option is option B. So this figure is the correct figure. Now going to the next question. Here again it's something related to the prism. Let's see what happens here. Already we have discussed that in a prism, when the light is coming, white light is coming, hitting here, it will get dispersed. On top we will have red and at the bottom we'll have violet. So violet, indigo, blue, green, yellow, orange and then red. Okay, then let's come to the question. In the following diagram showing dispersion of white light by a glass prism, the colors P and Q respectively are. So what is P and what is Q? So first we should write P and then Q. So P I think it's the last one. So last one for us is violet. And Q is the first color, that is red. So violet and red will be the correct option. So option A is violet and red. This one is wrong because it's orange. Here red and violet. No, it's the opposite. Here red and blue. That's also wrong. So the correct option is option A. Again, one more question. In the following diagram, correctly marked angles are. So when we have a prism and when a ray of light is coming and striking, here we have a normal here and this angle is called angle of incidence. Then afterwards it will bend. So here the angle made with the normal here is called angle of refraction. Again, from here it will come out and here we have a normal. So this angle is called angle of emergence and this angle is called angle of prism, which is represented usually as A, angle of prism. Then again, if you extend this incident ray and if you extend this emergent ray, the angle made between them is called angle of deviation. So these are the angles that we have in a prism. Let's analyze this one. Here, first of all, we have to find out the correctly marked angles. Let's see. Angle I. See, angle I is marked here. Actually, it is supposed to come with the normal. So, angle I is wrong. It's not correct. So, angle I cannot be considered. Now, angle of refraction. So, angle of refraction, if you see, this is the normal, but refraction is marked here. Again, that is also wrong. Then, coming here, angle of deviation is marked here. So, that is also wrong. Deviation should be, we should extend the incident ray and the emergent ray, and the deviation should come somewhere here, but it is marked here, so it's wrong. But angle of prism, that is correct, and this is the normal and this is the emergent ray. In between we have the angle of emergence. So angle of prism and angle of emergence, both are correct. Let's see which option is correct. So angle A and angle E. Here angle R is also coming, so it's wrong. Here angle I is also coming, it's wrong. Even here also it's wrong. Angle A, angle E. So it's only coming in option D. So option D is the correct option. Now our third question, that is question number 32, is assertion reason question. So our third question, that is assertion reason question, also might come from the light chapter. See, when we analyze assertion reason question, first of all see whether the assertion is correct or wrong. Then see whether reason is correct or not. Then analyze whether the reason is the correct reason or is it explaining the assertion properly. This is the way in which we should analyze it. Let's see this one. Assertion is like this. Near point of a hypermetropic eye is more than 25 centimeter away. So they are saying about hypermetropia. Let's see if this is the eye. Inside the eye we have convex lens. We will be usually able to see from 25 centimeter to infinity. So this is the normal vision. Here this part normal humans won't be able to see. This person is a hypermetropic person, which means he can't see this 25 centimeter as well. So he will be able to see somewhere from here. The point is not given to us, we don't know. So anyway, he can't see this much. Even 25 centimeter to some distance far away, he won't be able to see. He'll be only able to see in this gap. Okay. So now come back to the assertion. The near point of a hypermetropic eye is more than 25 centimeter. That is correct. The near point will not be 25 for that person. It will be far away. It will be far away from the person, which means the statement is correct. So for a hypermetropic person, the near point is not 25 centimeter. It is further away from him. So the statement is correct. So our assertion is correct. Now come to the reason. Hypermetropia is corrected using spectacles containing concave lens. For hypermetropia, usually we won't be using concave lens, we'll be using convex lens. So this statement is wrong. Where do we use concave lens? Concave lens is usually used for myopia, to correct myopia. So here the statement is wrong. So as per this, assertion is correct and reason is wrong. We'll go to one more. Two bar magnets attract when they are brought near to each other with the same pole. Two bar magnets attract when they are brought near to each other with the same pole. So we know the properties of bar magnet. When north pole and north pole comes together, or when south pole and south pole comes together, they will repel each other. Like poles will repel each other. When unlike poles, maybe north and south comes together, they will attract each other. So like poles repel each other, unlike poles attract each other. Here, as per this, they are saying that two bar magnets attract when they are brought near to each other with the same pole. Like poles will not attract, they will repel. So this statement is wrong. Assertion is wrong. Come to reason. Unlike poles will attract each other. This is correct. Unlike poles will attract each other. So assertion is false, reason is true. Okay. As per the model question paper, the assertion reason question is also coming from the light topic, but we don't know. So we have just discussed one question from the electricity chapter as well. Going to this one, this is a good question. Let's see. In electric circuits, wires carrying current in opposite directions are often twisted together. You might have seen the wires that we connect. Usually, if we have a wire like this, then the other wire also will be twisted and kept like this. So why is it kept like this? In electric circuits, wires carrying current in opposite directions. See, if this one will be carrying current in that direction and this one the opposite direction in a circuit, so they are often twisted together. This usually happens. So this is a correct statement. Now come to the reason. If the wires are not twisted together, the combination of the wires forms the current loop. The magnetic field generated by the loop might affect adjacent circuits or components. This is also correct. We'll tell you why. See, suppose our wire is like this. We have two wires like this. One is carrying current in that direction, another one is carrying current in this direction. So here, if you consider it like a straight current carrying conductor, then when it is going in that direction, inside this our magnetic field is going into the paper, into our screen. Now when we consider this one, it's coming out of the screen, so both will get cancelled each other. Suppose if the loop is very big, if you have a very big loop like this, or if we have the wire like this for long distance, then here we have a lot of area, and the distance between this or the area between this will affect the magnetic field. So when there is more area between this, or when we have a big loop here, it will create a magnetic field, and that field can affect some of the components. So that's why usually the wires are twisted. So here assertion is also correct, reason is also correct, and the reason is explaining the assertion properly. So usually we'll go for option A, that is assertion is correct, reason is correct, and the assertion is explaining the reason properly. So today we have seen 3 questions, that is question number 30, 31 and 32, which probably might come from the light topic in physics. Before stopping, let's see the official paper of CBSE as well. Let's see the questions. Let's see from where they have asked all. So the first question, that is question number 30. Arnav was making notes and he wrote down the following statements from his understanding of reflection from curved surfaces. First statement is like this. Concave mirrors can produce both real and virtual images depending on the position of the object. We know concave mirrors, they'll form all types of images. They'll form real images or virtual images. That's correct. So the first statement is correct. Now coming to the second one, convex mirrors always produce real inverted images. This statement is wrong. This convex mirror is the mirror that we use as a rear view mirror or side view mirror in a vehicle. So there we are getting an erect image and diminished image. Here they are saying it will be a real and inverted image. So the statement is wrong. Go to the third option. In both concave and convex mirrors, they are both mirrors. The image location can be determined using the mirror formula 1 by f is equal to 1 by v plus 1 by u, where f is the focal length, v is the image distance, u is the object distance. So this is correct statement. Since both are mirrors, we can use this mirror formula. So this statement is also correct. So our correct statements are option 1 and option 3. So from here, let's see which option is same as it is. 1 and 2, it's wrong. 1, 2 and 3, it's wrong. 2 and 3, wrong. 1 and 3. So 1 and 3, option D is the correct option. Let's go to the next one. Choose the correct option from the below, which explains the reason for us to perceive the day sky as blue. So we know it's because of scattering. Let's see which option says that one. First option is, as sunlight passes through the atmosphere, shorter wavelengths such as blue are scattered more than the other colors. Actually, this is the correct option. We have studied that one. Anyway, let's read the others as well. The sky appears blue because all colors are scattered equally. No, that is not correct. Then the blue color of the sky is due to longer wavelength like red and orange scattering more than the shorter wavelengths. This is straight opposite. This is wrong. Then atmosphere contains blue colored particles. There are no particles like that. This is also wrong statement. So option A is the correct statement. Let's go to next one. That is assertion reason. First of all, let's read the assertion. A point object is placed at a distance of 26 cm from a convex mirror of focal length 26 cm. The image will not form at infinity. So let's see whether it will form at infinity or not. The question is, object is placed in front of a convex mirror. So we have a convex mirror and the object is placed in front of it. Its focal length is 26 cm. Actually, if this is a convex mirror, then the focal length doesn't matter, because whatever you keep in front of a convex mirror will be formed inside the convex mirror. It will be erect but diminished. We already know that. So as per this, they are saying that the image will not form at infinity. So anyway, it won't form at infinity. It will be forming inside the mirror. So the statement is correct. Assertion is correct. Coming to reason, for above given system, the equation 1 by v plus 1 by u equals 1 by f. Given v is equal to infinity, equation is okay, but they are saying that v, that is image distance, will be infinity. Image is formed inside the mirror. It will be less than the focal length value. Usually it is like that. So if the focal length is 26 centimeter, then anyway this value will be less than 26 centimeter. It cannot be infinity. So this reason is wrong. So assertion is correct, reason is wrong. So by this time you might have understood from where this MCQ questions in physics will come. Our question number 30, 31 and 32, the assertion reason question. What type of questions might come and from where they might ask all this will be clear to you now. In the upcoming classes, let's discuss about the remaining questions as well. Thank you. Study well for the exam.